For number 5, here I want to distribute that 1/3 to each piece, so the 8 will get a 1/3, and now when it comes into the 12, I'm actually multiplying. So I'm multiplying 12 over 1 times 1 over 3. I end up with 12 over 3, which in this case makes a lowest terms 4. Same thing will happen in the bottom. I will get 27 to the 1/3 power. I'll come back and work on that in a second. And then 1/3 times 30, well, 1/3 of 30 is 10. Come on, 0, there you go. So now I've got some numbers to clean up top. If you remember, 1/3 is another way of writing a cube root. So another way to think of my numerator is simply cube root of 8. That's something we should recognize as the whole number 2. So this top number can simply be replaced by a 2. Let me write down a little further. 2, I'll copy my x to the 4th, over my y to the 10th will not change. Again, in the same vein, my 27 to the 1/3 can be rewritten as the cube root of 27, which again we probably should recognize as the number 3. And then I have a lowest terms, nice clean final answer there for number 5. For number 6, since the power is exactly the same, I can multiply together the numbers that are basically underneath my cube root. If I'd like to see it rewritten as a cube root, I could write cube root of 21 times cube root of -3 if I wish. Either way we think about it, I can actually bring those together under a cube root as a single term. Now here's the question, can we have negative answers when we're talking cube roots? In the case of odd roots, yes we can. For example, the cube root of -8 actually happens to be a -2, because -2 times -2 is +4, times a third -2 is actually -8. So I can get an answer here. Let's try factoring. Cube root of 63, I see that will divide by a -3. And when I do, I get 21, and that divides by 3 and 7. Again, my index is 3. Do I have any groups of 3? Unfortunately, in this case, I do not. So I basically have to leave my answer as the square root of -63. There's not enough to factor out front and write a smaller whole number out front. That's number 6. Number 7 says to rationalize. In other words, make the denominator something nicer and positive. So our trick was to multiply by a fraction made up of the square root of 7 to match the bottom. When I play that trick and I combine the two numbers in the denominator, I end up getting a value of the square root of 49, which we all know is 7. My numerator up top, I can actually combine by multiplication and get 28x. And then I want to think about breaking 28 down into smaller parts. Instead of going to the fully factored form where I'd have 2 times 2 and circle those little 2's, I think we can survive by realizing if I factor out a square root of 4, which is your whole number 2, in front of my radical, and my leftovers will be my 7x. I can get a slightly cleaner answer using smaller numbers. So this looks like a decent answer for 7. Again, the point was to get the radical out of the denominator, and this is the trick by which we do that. For number 8, notice here very carefully that the 2 in front actually has its own power of a 1. Hence, he will not be moving to the bottom of a fraction, which is required to start to repair this -2/3. So as a first look, I want to shift to the bottom, getting rid of the negative there in my power. And now I want to think about this power. And I want to concentrate on the denominator now and keeping my parentheses around. I want to think about writing this as taking my exponent and busting it up into 2 pieces, using my denominator as the 1/3 power, that's another way of saying cube root, and the 2 up top squaring it. So I'm using this property of, let me go to a different color here, of distributing this one to this one, but I'm using it backwards, not to combine two things like we've done before, but to actually split them apart and to see kind of what's going on there. So I use this property of multiplying exponents backwards to basically split my 2/3 fraction. Now seeing what we have. This part inside I wish to do something with now. I wish to make that 4x squared. Let's multiply that out. So we'll replace those with 4x squared, and now we have something raised to the 1/3 power. We've learned that 1/3 powers are basically cube root. I'm still focusing just on my denominator, but if this is the case, we have a problem. In this one, we happen to have now another new square root in the bottom. I need to multiply by the cube root. I should have said cube root there, sorry. We have to multiply by the cube root of something. Now notice in the original, if we work on this prime factoring method that we heard the guy in the video yesterday, I already have two of things that I need. So really I only need to multiply by the third of each type to make a total collection of 3 items multiplied together. So this will give me 8x cubed, and I think we know that 8x cubed does have a perfect cube root, and that would be 2x down below. So if I multiply the bottom by the cube root of 2x, I also have to do the same thing to the top. Now what was up there before? If we look way back, there was only a 2 up there. So I have 2 cube root of 2x over 2x. And notice here is something we should probably repair before we're finally done. Those, of course, will cancel, leaving a final answer of cube root of 2x over x.